Good morning, students. In this video lesson, we are going to start a new chapter, Refraction of Light. In your previous class, you have learned about the phenomena related to light, that is, a reflection of light. When a light falls on the surface of the object and it turns back, the phenomena is known as reflection of light. We all know that light travels in a medium in a straight line path. When a light falls on the surface of an object, what are the possibilities that may occur? The ray of light may be absorbed by the surface of the object. The ray of light may get reflected back. The ray of light may penetrate and pass through this object. The ray of light may partially gets reflected and partially get refracted depending on the nature of the object. Now, a ray of light traveling in a medium in a straight line path, when comes across another medium in its way, what will happen? That is, when a ray of light traveling in a transparent medium comes across another transparent medium, will there be any change in the path of light, or will it continue on the same straight line path? The answer is the ray of light deviates from its straight line path. You can see in the diagram a laser torch is focused on the glass slab, and when this ray of light coming out from laser enters into the glass slab, it deviates from its straight line path what it has in its air. Similarly, the ray of light, when it comes out from the glass slab, deviates from its straight line path. So we come to know that a ray of light, while traveling in one transparent medium, comes across another transparent medium in its way. It deviates from its straight line path. This phenomena of bending of light is known as refraction of light. So we can define refraction of light as the bending of a ray of light from its straight line path at the interface which separates the two transparent medium. You can see the diagram. The bending of light occurs at the surface separating the two media. Now, why refraction takes place? What is the cause of refraction of light? Light travels with different speed in different medium. The speed of light in vacuum is 3 lakh kilometer per second, or you can say 3 into 10 to the power 8 meter per second. The speed of light when it enters in water, oil, glass, it will not remain same, it changes. And this change in speed of light is regarded as the basic cause of refraction. The more is the change in the speed of light while traveling from one transparent medium to another, the more will be the bending, the more will be the refraction. So, change in speed of light is the cause of refraction of light. Now, there is the term optical density. the speed of light in a medium is taken as indicator of optical density. The more is the speed of light in a medium, the less is its optical density. So we can make a table to depict the relationship between the optical density and speed of light. More is the optical density, less is the speed of light. Less is the optical density, more is the speed of light. So of the two media in contact, the medium with a smaller value of optical density acts as rarer medium, and the medium with larger value of optical density acts as denser medium. Now there is another term, refractive index. Actually, the ratio of speed of light in a given pair of media gives us the measure of refraction, that is the amount of bending. That is the amount of bending. A new term is defined by this ratio known as relative refractive index for a given pair of media, and symbol that is used to represent refractive index is read as mu. The relative refractive index of second medium with respect to first medium is equal to ratio of speed of light in the first medium to that of speed of light in the second medium. A refractive index or absolute refractive index of a medium is defined as the ratio of speed of light in vacuum to the speed of light in medium. It may be regarded as the measure of optical density. The more is the refractive index, the more is the optical density. So you can see that a refractive index is the measure of optical density of the medium. Of the two media, if one media is vacuum, the refractive index of the medium is known as absolute refractive index or simply refractive index, and in other cases the refractive index of the medium is termed as relative refractive index. So we can tabulate the relationship between the speed of light, optical density and refractive index as follows. The more is the speed of light, the less will be its optical density and lesser will be its refractive index. The less is the speed of light, the more is its optical density, the more will be its refractive index. Now, just now we have discussed that of the two media in contact, one is termed as rarer medium and one is termed as denser medium. The medium having higher value of optical density, higher value of refractive index is regarded as denser medium, and the medium with smaller value of refractive index, smaller value of optical density is regarded as rarer medium. Now, from our previous discussion, we know that when a ray of light while traveling in one transparent medium enters into other transparent medium, it deviates from its straight line path. It bends from its straight line path. Now the question arises, in which direction it will bend? If we draw a perpendicular at the point where the incident ray strikes the interface separating the two media, that perpendicular is known as normal, which is shown in the diagram. Now whether the ray of light will bend towards the normal or it will bend away from the normal. So it depends from which medium to which medium the ray of light is traveling. When the ray of light is traveling from rarer medium, enters into a denser medium, it bends towards the normal. The speed of light will decrease. The angle of refraction will be less than the angle of incidence. And when a ray of light traveling in a denser medium enters into a rarer medium, it bends away from the normal. That is, speed of light will increase when it travels from denser medium to rarer medium. At the same time, angle of refraction will be greater than the value of angle of incidence. These two facts is regarded as the two rules of refraction. When a ray of light passes from rarer medium to denser medium, it bends towards normal. When a ray of light passes from denser medium to rarer medium, it bends away from the normal. Thank you for watching.